Welcome to our comprehensive lecture series on the geography of India. Today, we are diving deep into a fascinating and highly dynamic topic, the Indian climate. We will explore why India's climate behaves the way it does, looking at everything from towering mountain ranges to shifting ocean currents. Let's start with a geographical paradox. The Tropic of Cancer passes right through the middle of India. This means the northern half of the country is technically in the temperate belt. However, India's climate behaves very much like a tropical country. Why? Because of the lofty Himalayan ranges. They act as a massive wall, blocking the freezing cold air masses moving south from Central Asia. Because of this protective barrier, winters in northern India are actually 3 to 8 degrees Celsius warmer than other places around the world located at the exact same latitude.
During the summer months, the sun is positioned directly overhead, giving the southern parts of India a climate that resembles an equatorial dry zone. But what about the north? The North Indian plains are swept by a fierce, hot, and dry wind known as the Lu. This wind originates from the Thar, Baloch, and Iranian deserts. The Lu drives temperatures in the north up so high that they match the intense heat of the south. Because of this, climatologists treat the entirety of India, south of the Himalayas, as a tropical country.
But we can be even more specific than just calling it tropical. The defining characteristic of India's weather is the seasonal reversal of winds over the Arabian Sea and the Bay of Bengal. This massive shift in wind direction brings about distinct wet and dry seasons. Therefore, to be highly precise, the Indian climate is classified as a tropical monsoon type, rather than just a standard tropical or half-temperate climate. While we classify the whole country under the tropical monsoon umbrella, the reality on the ground is incredibly varied. India exhibits high regional climatic diversity. This is entirely due to its vast topographical diversity. A region's specific climate is dictated by its latitudinal location, its altitude, how far it is from the moderating influence of the sea, and its relief, meaning the physical shape of the landscape, like mountains and plains. Let's look at rainfall to understand this diversity. While most of India enjoys distinct wet and dry seasons, places like the Thar Desert and the high-altitude desert of Ladakh barely see a wet season at all. The contrast in mean annual rainfall is staggering. In the northeast, Mawsynram and Cherrapunji in Meghalaya are drenched with around 1,100 centimeters of rain every year. Meanwhile, over in the west, Jaisalmer in Rajasthan rarely sees more than 12 centimeters annually. It's not just the amount of rain that varies, but the timing. During July and August, the Ganga Delta and the coastal plains of Odisha experience intense, heavy rainfall. But during those exact same months, the Coromandel coast, which includes Tamil Nadu and southern Andhra Pradesh, goes completely dry. Furthermore, the monsoon arrives at different times. Places like Goa, Hyderabad, and Patna usually welcome the southwest monsoon rains by the first week of June, while the parched lands of northwest India have to wait until early July. Temperature also showcases extreme regional diversity. We measure this using diurnal ranges, the difference between day and night temperatures, and annual ranges, the difference between summer and winter. The Thar Desert experiences the highest diurnal range. It can be scorching during the day and freezing at night. The Himalayan regions experience the highest annual range, with massive shifts between summer and winter. Conversely, coastal regions enjoy the lowest temperature ranges, staying relatively stable day and night all year round. To put these temperature ranges into perspective, consider the month of December. In parts of Jammu and Kashmir, the temperature can plummet to a bone-chilling minus 40 degrees Celsius. At the exact same time, folks living in India's coastal regions are enjoying a balmy 20 to 25 degrees Celsius. Generally speaking, most of India experiences moderately cold winters and extremely hot summers, while the Himalayas flip that script, enduring brutal winters but enjoying moderate, pleasant summers. Let's test this knowledge with a past exam question from 2002. You are given a station with an average annual temperature of 26 degrees Celsius, rainfall of 63 centimeters, and a small annual temperature range of just 9 degrees. Is it Allahabad, Chennai, Cherrapunji, or Kolkata? The correct answer is Chennai. The small temperature range of 9 degrees indicates a coastal location. Chennai experiences a tropical savanna climate, staying warm year-round with winters around 24 degrees and summers around 30 degrees, alongside moderate rainfall. Here is another question, this one from 2001. It provided a map with the interior of peninsular India shaded in, asking for the mean July temperature of that specific area. The options range from 22.5 to 32.5 degrees Celsius.
The correct answer is C, 27.5 to 30 degrees Celsius. The shaded area represents the tropical wet and dry region of the Deccan Plateau. During July, which is the monsoon season, cloud cover and rain bring the intense summer heat down to this specific moderate range.
Now that we've seen the features of the climate, we need to understand the why. There are 9 major factors that influence and shape the Indian climate. These include latitude, distance from the sea, the Himalayas, physiography, monsoon winds, upper air circulation, El Niño and La Niña, tropical cyclones, and western disturbances. We are going to examine each of these factors in detail.
The first factor is latitudinal location. The area south of the Tropic of Cancer lies in the tropics, receiving high solar insolation, or sunlight. This results in extreme summers and moderate winters. The area north of the tropic lies in the warm temperate zone, receiving less direct sunlight. However, as we discussed, summers are still incredibly hot here because of the Lu wind, while winters get very cold due to weather systems called western disturbances. Note that coastal regions maintain a moderate climate, regardless of their exact latitude.
The second factor is distance from the sea, a concept known as continentality. Water heats and cools much slower than land. Therefore, coastal regions enjoy a moderate, equable, maritime climate. Because they are on the coast, they are also the first to intercept incoming monsoon winds, resulting in heavy rainfall. Conversely, interior locations are too far away to feel the sea's moderating effects. They experience an extreme continental climate, with harsh summers, cold winters, and generally less rainfall. This brings us to a 2005 exam question asking to arrange cities by decreasing annual rainfall. The correct sequence is Kolkata, Kochi, Patna, and Delhi. While Kochi on the west coast gets massive rainfall from the southwest monsoon, Kolkata actually edges it out in some historical datasets because it receives significant rain from both the southwest and northeast monsoons, plus heavy precipitation from Bay of Bengal cyclones. Patna gets moderate rain, and Delhi, being the furthest inland, experiences the strongest continentality effect and gets the least. The third major factor is the Himalayas. These mountains act as a massive climatic divide. In winter, they shield the subcontinent from the freezing, dry air of Central Asia. In summer, they act as an insurmountable physical barrier for the moisture-laden southwest monsoon winds, forcing the air to rise and drop its moisture as orographic rainfall. They also split the Bay of Bengal monsoon branch, sending one part across the Indian plains. Without the Himalayas, those monsoon winds would just blow straight into China, leaving North India a barren desert.
You might wonder, if the Himalayas guide the monsoon winds across the northern plains, why does rainfall decrease as you move from east to west? It's simple. As the winds travel westward from Bengal towards Punjab, they drop rain at successive low-pressure zones. By the time they reach Delhi and Haryana, the clouds are mostly empty. So why aren't Haryana and Punjab deserts like Rajasthan? Because they are saved by winter rainfall brought in by weather systems called western disturbances.
The fourth factor is physiography, which is the primary determinant of a region's mean annual rainfall. This introduces the rain-shadow effect. When moisture-bearing winds hit a mountain, the side facing the wind, the windward side, gets heavy orographic rain. But once the air crosses the peak, it has lost its moisture, leaving the leeward side dry. For example, the Western Ghats ring out the monsoon winds, giving the west coast heavy rain, but leaving vast interior areas like Maharashtra, Karnataka, and Telangana in a dry rain shadow.
So, if physiography dictates rainfall, why is the Thar Desert in Rajasthan so dry? First, there's no orographic barrier. The Aravalli mountain range runs parallel to the monsoon winds, so it doesn't block them, and the mountains aren't tall enough to force the air up anyway. Second, the winds here are moving horizontally towards a massive low-pressure zone in Tibet, meaning there's no vertical convection to build rain clouds. Finally, in winter, a high-pressure belt causes air to sink and diverge, which actively suppresses any storm formation.
On the opposite end of the spectrum, why do Mawsynram and Cherrapunji in Meghalaya get a world record 1,100 centimeters of rain? This is due to a phenomenon called the funneling effect. The unique shape of the mountains physically funnels moisture-laden clouds from the Bay of Bengal into a very narrow gorge. This creates an extraordinary density of clouds. When these densely packed clouds are forced up the steep slopes of the Khasi Hills, they unleash massive, continuous downpours.
The fifth, and arguably most dominating factor, is the monsoon winds themselves. The Indian monsoon has distinct characteristics. It arrives with a sudden, violent burst, progresses gradually across the landmass, and then slowly retreats. The complete seasonal reversal of these winds defines the Indian seasons. The southwest monsoon from the ocean brings the vast majority of India's rain. Later in the year, the northeast winter monsoon blows from land to sea, picking up moisture over the Bay of Bengal to drop rain almost exclusively on the Tamil Nadu coast.
Factor 6 takes us high into the atmosphere, upper air circulation, specifically jet streams. During winter, the westerly jet stream blows at incredible speeds over the subtropics. Its southern branch is crucial because it steers winter storms into India. In summer, as the sun shifts north and the massive Tibetan Plateau heats up, the upper air circulation reverses. The westerly jet is replaced by the easterly jet stream. This high-altitude shift is the trigger that causes the sudden burst of the southwest monsoon at the surface. Let's look closer at Factor 7, western disturbances. These are actually the remnants of temperate cyclones that originate thousands of miles away in the Mediterranean Sea. Steered by the westerly jet stream at an altitude of about 2,000 meters, they travel eastward, picking up fresh moisture from the Caspian and Black Seas along the way. Typically, 4 to 6 of these cyclonic waves hit northwestern India between October and April, though recent climate studies show they are increasingly arriving in the early summer.
When these western disturbances arrive, they drastically alter the weather. They cause an abrupt drop in temperature across northwest India, bringing winter rains to the plains, heavy snowfall to the Himalayas, and sweeping cold waves. But they aren't just a weather nuisance. They are economically vital. The gentle winter rain they bring, which can reach as far east as Patna in Bihar, is absolutely crucial for the survival and yield of standing rabi crops, such as wheat, barley, and mustard.
Factor 8 is tropical cyclones. These massive storm systems originate in both the Bay of Bengal and the Arabian Sea, heavily impacting peninsular India. During the main southwest monsoon season, cyclones frequently form in the Bay of Bengal, but they are generally of lower intensity. However, during the retreating monsoon season in October and November, conditions become ripe for high-intensity, destructive cyclones that frequently batter the eastern coast of India.
The final factor involves global ocean currents, El Niño and La Niña. El Niño is generally bad news for India. It suppresses the monsoon rainfall and reduces cyclone formation in the Bay of Bengal, though it increases it in the Arabian Sea. El Niño years frequently result in severe droughts. Conversely, La Niña is great for the Indian monsoon. It brings heavy rainfall and increases cyclone activity in the Bay of Bengal, often to the point where widespread flooding becomes the primary concern. You will often hear El Niño referred to as ENSO, which stands for El Niño Southern Oscillation. This is because it's a coupled system involving both the ocean and the atmosphere. The oceanic component is the physical warming or cooling of the Pacific waters. Warming is El Niño, cooling is La Niña. The atmospheric component is the Southern Oscillation, which is a massive seesaw of air pressure between the East and West Pacific. During El Niño, pressure drops in the east and rises in the west, disrupting global wind patterns, including the Indian monsoon.
Let's tie all these factors together with a matching question from the 1997 exam. Why is Madras warmer than Calcutta? Because of its lower latitude, closer to the equator. Why is there snow in the Himalayas? Due to high altitude. Why does rainfall decrease from West Bengal to Punjab? Because of increasing distance from the sea, meaning the winds lose moisture. And why does the Sutlej-Ganga plain get winter rain? Because of western depressions. Now that we understand the underlying factors shaping India's climate, we are perfectly positioned to explore how these elements come together to create the distinct Indian seasons.
Continuing our discussion on the Indian climate, let's break down the annual cycle. The monsoon climate of India is officially categorized into 4 distinct seasons: the winter season, the summer season, the southwest monsoon or rainy season, and finally the retreating monsoon season. We will examine the unique atmospheric conditions of each, starting with winter. The cold weather season, or winter, spans from November to March. During this time, the sun's apparent path shifts south of the equator, reducing the amount of solar radiation India receives. January stands out as the coldest month. If you are in India during this time, you will typically experience clear skies, low humidity, and cool, slow-moving northeast trade winds. Because the skies are clear, the heat escapes rapidly at night, leading to a very high diurnal range of temperature, meaning the difference between daytime highs and nighttime lows is quite large, especially in the interior parts of the country. Let's look at how these winter temperatures are distributed geographically. The 20 degrees Celsius isotherm acts as a dividing line, running roughly parallel to the Tropic of Cancer. South of this line, you don't really get a distinct winter. Places like Kerala and Tamil Nadu stay quite warm, hovering near 30 degrees Celsius. However, north of this line, winter is very distinct. The mean minimum temperatures drop to about 10 degrees in the Gangetic Plains and plummet to 5 degrees in the northwest. The absolute extreme is found in the Dras Valley in Kashmir, which is the coldest region in India, famously recording a freezing -45 degrees Celsius in 1908.
Temperature directly influences atmospheric pressure. Because northwest India experiences such low temperatures, the cold, heavy air creates a high-pressure zone. This is further amplified by air divergence induced by the subtropical jet stream. In contrast, the warmer South India maintains lower pressure. Naturally, winds want to flow from high to low pressure, so they move from the northwest towards the southeast. However, because the actual difference in pressure, known as the pressure gradient, is relatively small, these winter winds remain quite weak.
The typically calm and clear winter weather in northern India is frequently interrupted by weather systems known as western disturbances. These systems flow in from the west, intensifying over states like Rajasthan, Punjab, and Haryana before sweeping eastward all the way to Arunachal Pradesh. They are crucial because they bring light beneficial rain to the northern plains and vital snowfall to the Himalayas. Once a disturbance passes, it leaves behind widespread fog and severe cold waves, often dragging minimum temperatures down by 5 to 10 degrees below normal. Regarding extreme weather, winter is the season with the least tropical cyclone activity. As the season advances, the ocean surfaces cool down and the Intertropical Convergence Zone, or ITCZ, shifts far to the south, removing the energy needed for cyclones to form. However, it's not entirely quiet. Some cyclones do form in the Bay of Bengal and strike the eastern coast, bringing heavy rainfall to Tamil Nadu. Occasionally, these storms cross the southern peninsula into the Arabian Sea, or rare storms might even originate in the Arabian Sea itself. While winter is generally dry, precipitation does occur in specific regions through different mechanisms. The retreating winter monsoons pick up moisture as they blow over the Bay of Bengal, delivering crucial winter rainfall to the southeastern coast, particularly Tamil Nadu and parts of Andhra Pradesh, Karnataka, and Kerala. Meanwhile, up north, the western disturbances provide light rainfall. Interestingly, during winter, the amount of rainfall gradually decreases as you move from the northwest towards the east, which is exactly the opposite of what happens during the summer rainy season. Finally, the northeastern parts of India also get some winter rain from local weather systems. Let's apply this knowledge to a past exam question. Consider this assertion. Anticyclonic conditions form in winter when pressure is high and temperatures are low. This is true. Now, consider the reason. Winter rainfall causes these anticyclonic conditions. This is false. While winter rainfall can temporarily cool the immediate air, it does not create large-scale anticyclones. The true cause of these high-pressure anticyclones is the massive cooling of the entire continental landmass due to reduced sunlight during the winter months. Transitioning from winter, India enters the hot weather season, or summer, which lasts from March to June. Often referred to as the pre-monsoon period, this season is defined by soaring temperatures and very low humidity. This drastic change in weather is driven by high insolation, as the sun's apparent position shifts northward from the equator toward the Tropic of Cancer. As the sun moves north, the zone of maximum heat moves with it. In March, the southern parts of India bake at 40 to 45 degrees Celsius. By April, the intense heat shifts to central India. By May, Rajasthan takes the brunt of it, with temperatures reaching up to 48 degrees. And by June, the heat peaks in Punjab and Haryana. Historically, the highest temperatures ever recorded were over 50 degrees Celsius in Alwar and Ganganagar. It is also worth noting that the west coast remains slightly cooler than the east coast during this time, thanks to the prevailing westerly winds blowing in from the sea. This extreme heat gives rise to dangerous heat waves. They typically begin striking by the end of April and peak in May. These heat waves develop deep inland over Rajasthan, Punjab, and Haryana, far away from the moderating influence of the ocean. From there, they spread eastward into Uttar Pradesh and Bihar. Interestingly, strong northwesterly winds can actually block the cooling sea breeze from reaching the eastern coast, dragging these heatwave conditions all the way down into Odisha and Andhra Pradesh. However, if you go deep south, past 13 degrees north latitude, heat waves are quite rare because the surrounding oceans keep the climate moderate.
The intense summer heat causes the air to expand and rise, creating low atmospheric pressure across the entire country. However, despite this low pressure, the monsoon doesn't start immediately. This is because there is a strong, dynamically induced divergence of air in the upper atmosphere over northwest India that acts like a lid, preventing the southwest monsoons from arriving early. Down at the surface, the wind patterns change completely from their winter state, becoming generally light and highly variable in direction. The steep pressure gradients built up by the heat in northwest India give rise to specific, intense local winds. The most notorious of these is the Loo. Originating over the arid Iranian, Baloch, and Thar deserts, the Loo blows across northern India during May and June. These are strong, blistering hot, and dust-laden winds. A typical Loo starts blowing mid-morning, around 9 a.m., reaches its maximum punishing intensity in the afternoon, and blows at speeds of 30 to 40 kilometers per hour. Once it starts, it can persist for several days.
Alongside the Loo, the pre-monsoon season also brings violent dust storms known locally as Andis, or blinding storms. Driven by strong convective currents, these storms look like massive solid walls of dust and sand rolling across the landscape. With wind velocities reaching 50 to 60 kilometers per hour, they can reduce visibility to just a few meters in seconds. They are common across the northern plains, from Rajasthan to Bihar. Fortunately, they are short-lived, and the squalls and light showers that follow them bring a sharp, welcome, albeit temporary, drop in temperature.
Moving to the eastern and northeastern parts of the country, the intense summer heat creates strong upward convection currents. When these rising currents interact with the high-altitude westerly jet stream, they trigger severe frontal thunderstorms. These storms typically originate over the Chota Nagpur Plateau and are then pushed eastward by the prevailing westerly winds. Consequently, states like West Bengal, Odisha, Jharkhand, and the entire northeastern bloc from Assam to Mizoram experience a very high incidence of these powerful thunderstorms.
In West Bengal and its surrounding areas, these thunderstorms manifest as incredibly violent squalls blowing in from the northwest, earning them the name nor'westers. They pack wind speeds of 60 to 80 kilometers per hour and are accompanied by heavy rain, known as spring storm showers, and sometimes massive hailstones. Because they peak during the month of Vaisakha, locals call them Kala Baisakis, or the black storms. While their sheer violence can damage crops and endanger lives, the rainfall they bring is actually vital for the cultivation of tea, jute, and rice, which is why in Assam they are fondly called tea showers.
Down south, the summer heat generates its own localized convectional thunderstorms, which typically break out during the evenings and nights. Just like in the Northeast, these pre-monsoon showers are incredibly important for local agriculture and have earned specific local names. In Karnataka, they are called cherry blossoms or blossom showers because they trigger the flowering of coffee plantations. Meanwhile, in Kerala, Tamil Nadu, and Andhra Pradesh, they are famously known as mango showers because this timely rain is essential for the healthy ripening of the mango crop.
Looking at larger weather systems during the summer, the frequency and intensity of western disturbances gradually decrease as the season progresses, though the few that do arrive continue to drop snow on the high Himalayas. Conversely, tropical cyclone activity ramps up. The warm waters cause a steep rise in cyclones in April, doubling by May. About 3/4 of these originate in the Bay of Bengal. Interestingly, most of these severe storms initially move northwest, but then recurve to the northeast, ultimately striking Bangladesh and Myanmar, meaning very few actually make landfall on the Indian coast. To summarize precipitation during the summer, while it is largely a dry season, contributing only about 1% of India's total annual rainfall, it is not entirely rainless. The precipitation that does fall is highly regionalized. You have snow in Kashmir from fading western disturbances, slight rain accompanying northern dust storms, high-intensity downpours from the nor'westers in the east, and the agricultural thunderstorms along the southern coasts. This brings us to the most critical and dramatic weather system for the subcontinent, the southwest monsoon season. Also known as the rainy season or the hot, wet season, it dominates the Indian climate from June through mid-September, completely transforming the landscape and the economy. The sudden arrival of the monsoon clouds and rain brings immediate relief from the brutal summer heat, dropping temperatures by 3 to 6 degrees Celsius almost overnight. Because the sky is blanketed with clouds, the diurnal range of temperature becomes very small. However, the cooling isn't uniform. Areas that miss out on the rain, like the desert west of the Aravalli Range and the coast of Tamil Nadu, stay hot, with temperatures remaining above 30 to 40 degrees. Conversely, areas receiving torrential rain, like the Western Ghats, become quite cool. temperatures will spike again whenever there is a pause in the rain, and eventually rise in September as the monsoon begins to withdraw. The mechanics of the monsoon are driven by massive pressure differences. The intense summer heat anchors a deep low-pressure zone over northwest India. The intertropical convergence zone, now acting as the monsoon trough, shifts north to lie along the Ganga Plain. Because atmospheric pressure increases steadily as you move south over the ocean, moisture-laden winds are drawn in from the Arabian Sea and the Bay of Bengal. They blow from the southwest to the northeast across the peninsula. Interestingly, once these winds hit the topographic barriers of the north, they are deflected, moving from east to west across the Indo-Gangetic Plain.
The arrival of the monsoon is a spectacular meteorological event. It is the lifeblood of the country, providing roughly 87% of the rainfall for the Indian plains. The winds advance quickly. They typically reach the Andaman and Nicobar Islands by May 20th and hit the mainland at Kerala by June 1st. This arrival is rarely gentle. It usually hits with a lot of thunder, lightning, and torrential downpours, a phenomenon aptly termed the monsoon burst. While June 1st is the average, the actual onset can vary by a week or so depending on global weather conditions.
The monsoon doesn't rain continuously for 4 months. It frequently experiences dry spells, known as breaks. These breaks occur when the monsoon trough suddenly shifts northward to the foothills of the Himalayas. When this happens, rainfall drops sharply over the central and northern plains. However, it's not dry everywhere. The shift actually causes a surge in rainfall along the Himalayan foothills, the northeast, and the southeast peninsula. On average, you can expect 1 or 2 of these breaks every season, most typically occurring around the second week of August.
A massive portion of the monsoon rainfall isn't just from the steady winds, but from intense low-pressure systems called depressions. About 3 to 4 of these form every month. Because they need constant moisture to survive, they are literally sucked inland through the large, wet deltas of great rivers like the Ganga, Mahanadi, and Godavari. As they track across the country along the ITZC, they dump heavy rain over central and northern India. In fact, if these depressions fail to form, or if they change their usual track, it directly results in drought conditions for those regions.
To summarize the nature of the southwest monsoon, we can identify several chief characteristics. First, it is highly concentrated between June and September. Second, it is heavily orographic, meaning mountains dictate where the heaviest rain falls. Third, rainfall decreases the further inland you go. Fourth, it is intermittent, punctuated by dry breaks. Fifth, it is highly uneven, with massive spatial variations across the country. And finally, it is notoriously unreliable. It can arrive late or withdraw early, which can cause devastating damage to agricultural cycles. As the monsoon winds cross the equator and hit the southern tip of India, the peninsular shape of the country splits the winds into 2 distinct branches, the Arabian Sea branch and the Bay of Bengal branch. The Arabian Sea branch is significantly more powerful for 2 reasons. The Arabian Sea is larger, and the entirety of its wind current slams directly into India. In contrast, only a portion of the Bay of Bengal current enters India, while the rest bypasses it towards Southeast Asia. Eventually, these 2 branches sweep across the country and merge together around Delhi by late June. Let's track the powerful Arabian Sea branch, which further divides into 3 streams as it hits the mainland. The first stream strikes the west coast perpendicularly. It is forced to rise over the towering Western Ghats, resulting in massive orographic rainfall, dumping 400 to 500 centimeters of rain on the windward side. However, once the air crosses the mountain crest and descends, it warms up and loses its moisture, causing rainfall to drastically plummet to just 30 to 50 centimeters. This creates a distinct narrow rain shadow desert, or belt of aridity, immediately on the leeward side of the mountains. The second stream of the Arabian Sea branch takes a different path. Instead of hitting a mountain wall, it funnels through the narrow rift valleys of the Narmada and Tapti rivers. Because there are no major mountain obstacles across these rifts to force the air upward, this stream doesn't drop much rain near the coast. Instead, it carries its moisture deep into the heart of the country, eventually bringing vital rainfall to central Indian regions like Nagpur. The third stream travels northwards toward Rajasthan. However, its path runs parallel to the Aravalli Range. Because the winds blow alongside the mountains rather than crashing into them, the air isn't forced to rise and cool. Consequently, it drops very little rain, which is the primary reason why the vast expanse of Rajasthan is a desert. There is one notable exception. Mount Abu, located on the southeastern edge of the range, catches enough of an orographic effect to receive about 170 centimeters of rain, standing as a green oasis in the dry plains. Meanwhile, on the other side of the country, the Bay of Bengal branch divides into two streams. The first stream heads straight over the Ganga-Brahmaputra delta and slams into the hills of Meghalaya. Here, the unique funnel shape of the valleys forces the moisture-laden winds rapidly upward, resulting in some of the most intense orographic rainfall on the planet. This is where you find Cherrapunji and Mawson Ram, located on the southern slopes of the Khasi Hills. Mawson Ram currently holds the record for the highest average annual rainfall in the world, receiving a staggering 1,221 centimeters.
The second stream of the Bay of Bengal branch hits the towering, impenetrable barrier of the Himalayas. Unable to cross over, the winds are deflected westward, funneling up the Gangetic Plain. As this stream travels inland from east to west, it continuously drops its moisture. Because it is moving further away from its oceanic source, the amount of rainfall it delivers steadily declines the further west it goes, until it eventually merges with the Arabian Sea branch near Delhi.
Looking at the map of the monsoon, you might wonder why the southeastern state of Tamil Nadu remains relatively dry while the rest of the country gets soaked. There are two main reasons. First, it sits squarely in the rain shadow of the Western Ghats, meaning the Arabian Sea current has already dumped its rain before reaching it. Second, the Bay of Bengal current flows parallel to the Tamil Nadu coast, so the winds never strike the land perpendicularly to be forced upward into rain clouds. Because it misses out on the southwest monsoon, Tamil Nadu relies heavily on the next phase of the climate cycle, which we will explore next, the northeast retreating monsoon. The retreating monsoon season, also known as the northeast monsoon season, marks a significant transition in India's climate. This phase begins with the withdrawal of the southwest monsoon, typically spanning from mid-September to November. Unlike the sudden, dramatic burst of the advancing monsoons we see in early summer, the withdrawal process is much more gradual, taking about 3 months to complete. Let's trace how this withdrawal happens geographically. The monsoon begins its retreat from the extreme northwestern end of the country in September. By October, it has withdrawn from the Indian peninsula. Finally, it leaves the extreme southeastern tip of the country by December. It's a slow, steady march backwards across the subcontinent. To illustrate this gradual process, let's look at two different regions. The southwest monsoon reaches Punjab in the northwest around the first week of July and withdraws quite early, by the second week of September. In contrast, it reaches the Coromandel coast in the southeast much earlier, in the first week of June, but doesn't fully withdraw from there until mid-December. This shows how the duration of the monsoon varies drastically across the country. As the monsoons retreat, the thick cloud cover that blanketed the subcontinent disappears, leaving behind clear skies. This lack of insulation has an immediate effect on the temperature. Daytime temperatures start falling steeply. Furthermore, without clouds to trap heat at night, the diurnal range of temperature, the difference between daytime highs and nighttime lows, increases significantly. During this season, the low-pressure monsoon trough that drove the summer rains weakens and gradually shifts southward. Interestingly, unlike the highly anticipated southwest monsoon, the onset of the northeast monsoon isn't clearly defined by a single meteorological event. Instead, the direction of winds over large parts of the country becomes heavily influenced by local, shifting pressure conditions. The retreating monsoon season is notorious for something else: cyclones. Some of the most severe and devastating tropical cyclones originate in the Indian Seas during this time. The Bay of Bengal is particularly active, spawning far more cyclones than the Arabian Sea. The peak danger period for these storms is throughout October and the first half of November. Let's look closer at the Bay of Bengal cyclones. In October, they typically originate between 8 and 14 degrees north latitude. They usually start moving in a westerly or northwesterly direction. However, many of them recurve, changing their path towards the northeast. Nearly 55% of these cyclones cross or severely affect the Indian coast, making the coastal belts of Tamil Nadu, Andhra Pradesh, Odisha, and West Bengal highly vulnerable to their destructive force. Sometimes these storm systems undertake a fascinating journey. Cyclones that strike the eastern coast of India, south of the 15 degrees north latitude, may actually cross the entire southern peninsula. While they weaken during this process over land, once they enter the warm waters of the Arabian Sea, they often re-intensify into dangerous cyclonic storms. The Arabian Sea produces its own cyclones too. These typically originate between 12 and 17 degrees north in October and slightly further south in November. Generally, these storms move in a northwesterly direction, away from the Indian subcontinent.
However, about a quarter of them recurve to the northeast, eventually striking the coasts of Maharashtra or Gujarat.
While the rest of the country experiences clearing skies, northwest India faces a different phenomenon: western disturbances. These weather systems bring cloudy skies and light rainfall to the plains. In the higher altitudes of Jammu and Kashmir, Himachal Pradesh, and the Kuman Hills, this precipitation falls as much-needed snow, which is crucial for the region's glaciers and winter crops.
Overall, precipitation during the retreating monsoon season is minimal for most of India. Humidity drops and the land dries out. However, there is a major exception. The months of October and November constitute the primary rainy season for Tamil Nadu and the adjoining areas of Andhra Pradesh, south of the Krishna Delta. It also serves as a secondary rainy period for Kerala.
Why does the southeast get rain when the rest of the country is dry? As the retreating monsoon winds blow from the northeast, they travel over the Bay of Bengal. During this passage over the ocean, these previously dry winds absorb a massive amount of moisture. When they finally strike the southeastern coast of India, they release this moisture as heavy rainfall. Moving on to India's annual rainfall, which combines both the southwest and retreating monsoons. Meteorologists use isoyets, lines connecting places with equal rainfall, to map this. Areas of very high rainfall, receiving over 200 centimeters annually, include the western slopes of the Western Ghats and the northeastern states. Meghalaya, aptly named the abode of clouds, is the wettest region, with Mausan Ram and Cherrapunji recording staggering annual averages of over 1,100 centimeters. Next, we have areas of high rainfall, receiving between 100 and 200 centimeters annually. This zone covers a vast portion of the country, including the eastern slopes of the Western Ghats, the fertile northern plains, and large central and eastern states like Odisha, Madhya Pradesh, Andhra Pradesh, and Tamil Nadu. These regions receive adequate rainfall to support extensive agriculture. Areas receiving low rainfall, between 50 to 100 centimeters, are often located inland or in rain shadow zones. This includes eastern Rajasthan, Punjab, Haryana, and parts of Gujarat and Maharashtra. Crucially, it also encompasses the interior Deccan Plateau, the rain shadow regions of Karnataka, Telangana, and Andhra Pradesh, where the Western Ghats block the moisture-laden winds.
Finally, areas of very low rainfall receive less than 50 centimeters a year. These are India's desert and semi-desert regions. The harsh, arid landscapes of western Rajasthan and the Kutch region of Gujarat fall into this category. Additionally, the high-altitude cold desert of Ladakh in the north is also starved of precipitation, as it lies far beyond the reach of the monsoon winds.
Let's test our understanding with a past UPSC question. We have an assertion: Bangalore receives much higher average annual rainfall than Mangalore. And a reason: Bangalore has the benefit of receiving rainfall both from southwest and northeast monsoons. Take a moment to consider if the assertion is factually correct, and if the reason is true and properly explains it.
The correct answer is D. The assertion is false, but the reason is true. Mangalore actually receives significantly more rainfall than Bangalore because it sits right on the coast facing the Arabian Sea, catching the full force of the monsoon. Bangalore is located inland on the Deccan Plateau, in the rain shadow of the Western Ghats, which drastically limits its moisture. However, the reason statement is factually true. Bangalore does receive some rainfall from both the southwest and northeast monsoons, just not enough to surpass Mangalore.
Because India's geography is so diverse, classifying its climate is a complex task. When doing so, geographers generally give more weight to rainfall than to temperature. This is because across the Indian subcontinent, variations in rainfall are far more extreme and impactful than variations in temperature. We will examine two prominent systems used to map these regions: Stamps classification and Köppen's classification.
Let's start with Stamps classification. Stamp used a specific temperature metric, the 18 degrees Celsius isotherm, for the mean monthly temperature in January. This imaginary line, which roughly parallels the Tropic of Cancer, divides India into two broad halves: a temperate or continental zone in the north and a tropical zone in the south. He then further subdivided these two major zones into 11 specific regions based on local rainfall and temperature patterns. Here is a visual representation of Stamp's 11 regions. You can clearly see the divide between the northern continental climates and the southern tropical climates. Let's break down the specific characteristics of the regions within these two broad categories, starting with the north. In temperate India, Stamp identified 5 regions. The Himalayan region experiences very cold summers and heavy rainfall, especially in the east.
The northwestern region, covering parts of Punjab and Jammu and Kashmir, has moderate rainfall. The arid lowland is the harshest, encompassing the Thar Desert and Kutch, where summer temperatures can soar to 48 degrees Celsius and annual rainfall is a meager 40 centimeters or less. Continuing in the north, the region of moderate rainfall covers the agricultural heartland of Punjab, Haryana, and western UP, receiving 40 to 80 centimeters of rain. Finally, the transitional zone covers eastern UP and Bihar. As the name suggests, it bridges the gap between the moderate rainfall areas to its west and the heavy rainfall areas to its east, receiving 100 to 150 centimeters annually.
Moving south of the isotherm into tropical India, Stamp identified 6 regions. The region of very heavy rainfall covers the northeastern states, receiving over 200 centimeters. The region of heavy rainfall spans the eastern states like West Bengal and Odisha, getting 100 to 200 centimeters. The region of moderate rainfall lies in the interior peninsula between the Ghats, receiving 50 to 100 centimeters.
The coastal areas of tropical India are distinct. The Konkan coast from Mumbai to Goa receives over 200 centimeters of rain. Further south, the Malabar coast from Goa to Kanyakumari is even wetter, exceeding 250 centimeters. Finally, the Tamil Nadu region, which, as we learned, relies heavily on the retreating monsoon, receives a moderate 100 to 150 centimeters of rainfall annually.
The second major system is Köppen's classification. Unlike Stamp, who used a single temperature line, Köppen based his system on the close relationship between climate and natural vegetation. He selected specific, calculated values of temperature and precipitation and mapped them against where different types of vegetation naturally grow. Using this method, Köppen divided India into 9 distinct climatic regions.
Here is Köppen's map. It uses a lettering system where capital letters denote broad temperature and precipitation patterns, and lowercase letters provide specific seasonal details. Let's decode these 9 regions and understand what these letter combinations mean for India's climate. First are the tropical monsoon climates. AMW represents a monsoon climate with a short, dry winter. This is found along the western coastal region south of Mumbai, receiving massive rainfall over 300 centimeters. AS is a unique monsoon type with dry summers and wet winters. This perfectly describes the Coromandel coast in Tamil Nadu, which gets its 75 to 100 centimeters of rain primarily from the winter retreating monsoon. Moving inland, A is the tropical savanna type, covering most of the peninsular plateau, with about 75 centimeters of rain. The B climates are dry. BSHW is a semi-arid steppe climate, found in the rain shadow of the western Ghats and parts of the northwest, receiving only 12 to 25 centimeters. BWHW is the true hot desert type, located in western Rajasthan, receiving less than 12 centimeters of rain a year. Finally, the cooler climates. Swag is a monsoon type with dry winters, dominating the vast Ganga Plain and Assam. DFC features cold, humid winters and short summers, found in high-altitude northeastern states like Sikkim and Arunachal Pradesh. ET is a tundra climate found in the mountains of Uttarakhand, and E is the polar type, found in the highest reaches of Jammu and Kashmir and Himachal Pradesh, where precipitation falls entirely as snow. That brings us to the end of our comprehensive look at India's climate. To wrap up, remember that the retreating monsoon brings dry, clear weather to most of the country, but is the lifeline for rainfall on the southeastern coast. It's also the peak season for dangerous cyclones in the Bay of Bengal. We've seen how wildly rainfall varies across the subcontinent and how geographers like Stamp and Köppen have created systems to make sense of this incredible climatic diversity. Keep these frameworks in mind as you study India's geography.